Hello world, welcome back to another tutorial. Today we're going to be talking about how to load 3D meshes into our game engine using .obj files. I've been dying to do this episode because this is where we go from just basic cube meshes or triangle meshes, you know, like 4 or 5 vertices, to thousands of vertices being loaded at a time, which is what most games have, right? They don't just have a bunch of cubes everywhere, they have really cool complex meshes. So I'm going to show you how to load those into our game engine. If you like this episode, hit thumbs up for me. If you want more content like it, hit subscribe. And if you want to chit chat about games and this episode or any other episode, hit me up on Discord. All of that information will be down in the link for the description link. I can't talk. Let's get into loading 3D meshes. All right, folks, like always, I put together a little keynote to talk about exactly the material we're going to cover. So right now we're going to talk about loading 3D meshes from files. So how are these 3D meshes created? Well, basically there's other 3D modeling software out there like Blender or Maya or all other sorts of 3D modeling software where you can go and drag vertices all around and make these awesome shapes and add normals and texture coordinates and all that jazz to the model in a tool. And then once we've created that mesh in that tool, we can export a 3D mesh. This 3D mesh has all of our triangle information on it. Now, the best way to export it, well, not best way, but a way to export it is to use a .obj file. But vertex data, texture coordinate data, and normal data are inside of this OBJ file. So all of the 3D mesh information is contained inside of the OBJ file. This is what the inside of an OBJ file looks like. It's kind of a lot of stuff going on, but it's really easy to read. If you were to just right click it and open it with like text edit or something, you know, some text editor, you'll see all of this on the inside. So we're going to talk about this line by line and what each line means. So the first 2 lines are comments. So they say wavefront exported by Milkshape 3D by Travis Offermat. This line is going to be the material file. You can tell it's the material file because it says mtl-lib, material library, because we can add multiple materials to our library. And then it has a file called cruiser.mtl, so cruiser.material. And basically what's going to happen is when we make this cruiser OBJ and we drag it into our game engine, we're also going to want to drag alongside of that the cruiser.mtl file because that contains important information that we're not talking about in this episode, but that does have material information. The data underneath that is going to be our vertex position, and you can tell it is the vertex positions of our mesh by the letter V. Basically, this is just a bunch of float 3s all the way down, and just remember that the V is for vertex positions. Another thing to note about these vertex positions is the order in which they are loaded onto the page. That is very important, and we'll talk about why in just a moment. If we keep scrolling down on this OBJ file, we'll notice that it says the count of the vertices up top. So in this case, it's 1364, which is, you know, kind of a lot of vertices. I'm glad we're using file loading now, not coding this from scratch. But underneath that, we have texture coordinates. So in the last episode, we talked about texture coordinates and how those work. Well, basically, all of these vertices are going to have texture coordinates automatically assigned to them. And so you'll see the VT represents vertex texture coordinates, I guess. And those are all float 2s all the way down. And we know they're in UV space because they go from 0 to +1. If we keep scrolling down in the OBJ file, we'll hit that texture coordinate count with the #, which marks a comment. And then underneath that, we have our normals. And we haven't talked about normals. And if you don't know what they are, don't worry about it. We will talk about them. If you do know what they are, there they are. So basically, VN is going to stand for normals of our mesh. Okay, so scroll down a little bit more. We see this jargon. Now, this might seem confusing if you've never seen this before, but it's fairly easy to understand. You'll remember that we loaded vertex position, texture coordinates, and normals in that specific order, right? We've created 3 different arrays of these values that we're loading in. Now that we have those values, we need to use these numbers right here. So each one of these represents one vertex of the triangle so each F on this for each row is a triangle, a different triangle with 3 vertices, and this 1, 1, 1 is one vertex of the triangle. All right, so this is the position index. The first value is going to be the position index. The second value is going to be the texture coordinate index, and the third value is going to be the normal index. Now, I know it looks like 1, 3, 2, where I put that. That's just saying that these could be whatever. They don't have to be just 1, 1, 1. They could be odd numbers, or it doesn't need to be 1, 1, 1, 2, 2, 2 every single time. That's just to clarify that. So I know you're noticing that it is 1, right? There's no zeros on this entire page. And the reason for that is because it is 1 indexed as opposed to 0 indexed like normal arrays. This is going to be 1 index. So when you're accessing the vertices of the arrays of the lists you just loaded from above, you're going to want to 1 index them. So when it says position at 1, we want the first vertice that was loaded, okay? And also, if there are no texture coordinates provided or no normals provided, that space is just going to be empty. So in this case, the texture coordinates aren't provided, so this spot is empty. It's just // n2. You see how that works? So if no texture coordinates are provided, that's what's going to be going on. So that is basic data of the OBJ file. There's a lot more stuff inside here that we just don't want to worry about right now. We'll talk about it later. Let's talk about these numbers just a little bit more in detail, and let's load up some triangles, theoretically for just 1 second. So let's start with these 2 triangles. So F and F. We have 2 triangles. Triangle 1 is on the top. Triangle 2 is on the bottom. You'll note that they're red and blue, and they're on the right side of the screen. Above, we've loaded our positions. So right here we have an array. Let's pretend this is an array of positions. Then we have our texture coordinates and our normals all loaded into multiple different arrays, okay? So now, for triangle 1, we're going to need to create triangle 1 with 3 vertices. How do we do that? Well, we grab the first value. So this is going to be 1, 1, 1. So we grab the first value of positions, the first value of texture coordinates, and the first value of normals. Now we need to add texture or vertex 2. So that one, we're going to just move it over. Now we're at 2, 2, 2, which will grab the second position, the second texture coordinate, and the second normal. And then we're going to do it for 3. So 3, 2, 3. So third position, second texture coordinate, third normal. And now we've loaded that triangle. We have that triangle. When we draw primitives, we'll be able to draw that triangle. Let's jump to the next triangle. We start back at the very beginning. So we're going to need 1, 1, 1. So 1, 1, 1. And then we go on to the triangle we haven't used yet, which is 4, 3, 4. And then we go back down here to 2, 2, 2. And we've loaded our sweet thing. I don't know what it is. It's just an example. But you get the idea. So now that we have this little guy and we understand how to load some triangles into our machine, now let's load this. This should be the output of our episode. I know. It's beautiful. Not the mesh underneath. I mean, you can do that, but let's go. Okay, to start off this code portion of our tutorial, let's go ahead and go to Google and type in this URL right here. I'll leave this in the description, so go just down there. And you'll notice that we have all of these OBJ formatted files. The one we're going to be using is right here, Travis Offermat's Cruiser. So if I just click that, that should download down here. And then if I open that, it'll open right here in my downloads folder. Now we have these 3 files. The first one's going to be cruiser.bmp, which is just basically the texture of our cruiser. The material file, if I open that with text edit, you'll see that it has material information. A is ambient, diffuse, specular, and that's going to be used in the future. And then down here we have the OBJ file, which has our actual model that's been created, somewhere. Probably says in the OBJ file. Now, if I open this, open it with text edit, we have all of that information that I told you about before. Now, what we could do is we could parse all of these ourselves. We can create our own system to parse it. Wouldn't be that bad. It's just kind of string parsing of a file and loading into some data structures. Could do that, but instead of doing that, we're going to use ModelIO. And what ModelIO is it's basically how Apple loads model meshes, and it's very fast, very easy to use. Okay, easy to use is not. I'm not going to say that. But we can use it. So we're going to be using ModelIO to load all of this vertex information into our game engine. So I'm going to close that. Over in our game engine, let's start coding. Over here in our game engine, I'm going to go to core, I'm going to go to res, and I'm going to create a new group, and I'm going to call that group cruiser, because this will contain all the cruiser information from our the folder we just downloaded. And then I'm going to drag all of those over into cruiser, make sure all of these little settings are selected, and now we have all of these files. Now if you click on cruiser.obj, you'll see the beautiful mesh in all of its glory. Okay, let's load this into our game engine. Right, so the first thing I'm going to do is I'm just going to go down into our entities and libraries, and we already have a mesh library that loads meshes. So we have custom mesh, which has triangle, quad, and cube, which are handwritten. But instead of doing it handwritten, we're loading model meshes. So I'm going to create a new class, and I'm going to call it ModelMesh, and that will inherit from mesh. I'm going to first, before I start implementing ModelMesh, I'm going to go up to mesh, remove vertex count from here because I don't actually need it there, and everything will build anyway except for this doesn't compile. And the reason is it doesn't have these two functions. So we need set instance count right there, and we need draw primitives right there. So to make use of the set instance count function that we created before, I'm going to create a private variable and I'm going to call it instance count. That will be an int, and I will set it equal to 1 by default. And then in set instance count, I will say self.instance count equals count. Boom. We will need an initializer in this, and the initializer will take in the model name. The model name will be a string, and that string will be the name of the file we're loading. So in our case, it's going to be cruiser. So we'd pass in cruiser as the model name. The only function that we need to add extra inside of this model mesh is a function, and I'm going to call it load model. And load model will take in the model name and will load from that file path. All right, so this is going to be the big guy of the entire model mesh class. So what I'm going to do is I'm going to paste in some code that I've already written just to save time. So give me one moment. Okay, I hope that was fast enough for you. Basically, now load model is all filled out. The only thing we're going to need to add that we haven't added yet is an array of meshes. So up at the top, I'm going to add private var meshes, and that will be an array of any. And I'll tell you why in just a second. So the reason our meshes is we're loading multiple meshes is because over in Blender or Maya, we could technically create different meshes in one file. You know, if we have a huge scene with buildings and items like cans and all sorts of things going on, we will want to load multiple meshes because each one of those meshes will have its own bounding box, right? It will have its own values associated with it. And so we're going to have an array of meshes loaded from an OBJ file. We could have implemented in our custom mesh class the exact same way, but since that was a simple thing to do, we might go back and do that. But yeah, we're going to need an array of meshes. So down in load model, we are first loading our asset URL. So that's going to just grab from the bundle main URL over here, whatever model name we passed in, which is cruiser in our case, with extension OBJ. So that's kind of hard coded. We might make that dynamic in the future. And if it doesn't find that asset inside of here, it will fatal error that the asset does not exist. That one's kind of straightforward. So this just kind of gets the URL to where it is. The next thing we're going to need is we're going to need the vertex descriptor because we have all these positions and texture coordinates and normals in this file, but we do need to describe how that data is laid out. Before we had a struct that we can specifically create a struct and pass that data through to the GPU. We don't have that now. We're not loading any structs, we're loading model data. And so what we're going to do is we're going to create a vertex descriptor using the ModelIO SDK. So we're going to say mtk ModelIO vertex descriptor from Metal, and we're going to pass in our basic vertex descriptor because we can use the same exact vertex descriptor. We're reusing code. Basically, it's just now it's going to need to wrap it with this ModelIO vertex descriptorness. So that's why we're doing that. Now, these 3 lines are pretty important because now that we've created our vertex descriptor with, attribute positions, when we're loading that, it doesn't really know what that is. So if we have a normal and a position in our data file, and they're both float 3s, which one is actually the normal, which one's the position? We have no idea. So what we need to do is we need to call descriptor.attributes at 0. So the first value is a position. So we're just going to set the name to position. So if I go to my types and metal types, you'll see vertex has position as our first value. And then the second one's going to be color, and the third one is going to be texture coordinates. And you'll see that I've had color and texture coordinate. Now we've laid these out, and there's tons of these. So if I say the name is MDL, vertex, attribute, data, normal, tangent, binormal, all sorts of cool stuff. But in our case, we just want position. All right, so now that we've described the way the vertex data is going to be loaded in, let's create our asset. So we're going to create a ModelIO asset using a buffer allocator. This allocator is going to be passed in and used to allocate memory, I suppose. We're going to create that with our device, and then we will generate the MDL asset using the URL from above, the vertex descriptor that we've just created right here, and the buffer allocator. And once we have our asset, we can now generate our meshes. Finally, an array of meshes, because our asset contains an array of meshes. So what we'll need to do is write a try catch. We will instantiate our meshes, which we added up here from the function mtkmesh.newMeshes. We'll pass in the asset with all the mesh data and the engine device. As you can see at the very end, we called .metalKit meshes. We could also call .modelIO meshes here. Basically, the difference in the two is going to be MetalKit meshes holds position data and all like our vertex data, and ModelIO meshes is going to be like some animation data, some bounding box data, and we'll use that in the future. But for now, all we need to do is load our MetalKit meshes. And that's for now. So now that we have our meshes created, we can render them. So it's basically just all we need to do now is iterate over every single mesh in our mesh array and render it. So I'm gonna go and paste some code down here. Give me 1 second, because this episode would be 40 minutes long. I'm wasting time now. All right, man, I'm getting really fast at copying and pasting, as you can see. So yes, let's talk about draw primitives. First thing we're going to do is we're going to convert our meshes from an any array into an MTK mesh array, because this could technically be an MDL mesh, which is what we get when we have ModelIO meshes. Or right here we have, this could also be an array of MDL mesh. And then we're going to return if that doesn't work, but it should work every single time. We're going to iterate over every single one of these meshes. And every mesh will have multiple vertex buffers. It might not. In our case, it actually doesn't, but it may. And for every single vertex in our array, we're going to want to set the vertex buffer at 0, just like we were before, using vertexBuffer.buffer and the offset of this vertex buffer. And then what we're going to want to do is we're going to want to iterate over all of the submeshes inside of our mesh. So basically, this is going to render all the submeshes. And what's cool is you can call render command encoder.draw index primitives. We haven't actually used this function yet. I haven't talked about drawing index primitives, and that's on me, not on you. But in this case, we're going to be drawing index primitives. Basically, what that means is instead of loading 2 vertices that are in the exact same position twice, or 4 times or 5 times, whatever we're loading it, we're only going to load it once, and we're going to instance that one vertex. So I could talk about that in the future if you guys want me to. Just let me know. But I forgot totally about that. But here we are saying the type is going to be the submesh.primitive type, the submesh.index count. As you can see, I've just used the submesh to grab all of these variables, and then the instance count is going to be the instance count set right here, so we can do some instancing. All right, so I know what you're thinking. The only thing we need to do is call load model, and our class is complete, and you will be completely correct. That was an easy class to write, not too shabby. So now that we have this ModelMesh class created, we can go ahead and go over here to fill library. Actually, at the top here, I'm gonna say case cruiser, because we're gonna add our cruiser to our library, which is going to be a ModelMesh that will have the model name of cruiser, and the key is going to be cruiser. We've loaded our mesh because we built such a badass engine. We've already created a ModelMesh, and we can use it pretty quickly. The only thing I would say is let's go back to our texture library. So go to Entities, Libraries, Texture Library, and we're going to load up our cruiser.bmp file. cruiser.bmp file is the texture that wraps our model. So what I'm going to do is I'm just going to go library.updateValue texture. We're going to do cruiser. I need to change the extension because now it's not a PNG, it's a .bmp. So we can say BMP there, and then the key is going to be, well, we need to add case cruiser right there. So for key cruiser dot cruiser. All right, so now that our texture is loaded and our model is loaded, let's go and use those. So instead of just making a game object with a texture type, I want to create a literal class that is represented, just for now, by the cruiser. So I'm going to go into Swift file. I'm going to create a new Swift file inside of game objects, by the way, and I'm going to call it cruiser. And you'll see it gets added down here in my game objects folders. I'm just going to put it right there. I'm going to close these real quick because move it on up. Keep that open. Yeah, keep these open. So now we have our cruiser. I'm going to import MetalKit here, class cruiser. That will be a game object. Let's write an init function. That doesn't take any parameters, but we will say super.init with the .cruiser value. And then I'm also going to call super.setName. I'll just say set name, and that will be cruiser, just so we have that in the debug info. And our cruiser class is completed. I will add something in just a second, but for now we have a cruiser game object. Let's go to our scenes, go into sandbox scene, and instead of loading up a quad, let's change this to a cruiser. So I'm going to replace that with cruiser, and then we're going to load up our cruiser and rotate our cruiser instead of that. So this is what your class should look like. Let's press play and see what happens. Aha! Yes! We have a spaceship, a cruiser. It's black. Okay, it's black. But if we go into cruiser and we say set color to a float 4, float 4, just like before, it's using that same exact shader that we're using for all of our other objects. Reuse of code, pretty cool engine. Now we have a color set. We can set the color to red if we really wanted to. But we don't want to set the color. What do we want to do? We want to set the texture, right? Because we loaded up the texture. Why not just set the texture to our cruiser texture that we've already loaded into our game engine? And if we've done everything correctly, we should have a texture wrapping this thing. So let's, first of all, I'm going to make it so we can rotate this in our scene. So right here in our do update, we can, instead of doing all that, just remove that code, and we will say if mouse.is mouse button pressed, we're going to do .left. We're going to want to rotate. Okay, so if we click, we want to rotate our cruiser. So I can say cruiser.rotate x. Now this might throw you off, but we can say mouse.get dy, because we want to rotate around the x-axis, but if we're moving up and down and the x-axis goes across, we want to be rotating this way. So it's just kind of thinking a little different. So we're going to need to get the dy gametime.delta time, and then cruiser.rotate y mouse.get dx times gametime.delta time. And the reason I'm doing it times delta time is, one, because we want it to be a consistent time, and get dy will be big. It'll be huge numbers. We don't want to rotate it that much. So now that we have the mouse button rotating, pretty cool. One other thing I want to do before we jump back in and start this project back up is I want to go into my cameras, go into debug camera, and field of view is how much space the camera takes up. So if its field of view is a lot bigger, it's going to be wider, and if it's smaller, it's going to be very small field of view. And so what we want to do is we want to make this variable. So what I'm going to do is inside of camera, I'm going to go private var underscore zoom, because that's basically what it is. It's zooming equals 45.0, and then I will set the field of view equal to self._zoom. And so now that we have the zoom, we can update it. So down in our doUpdate function, I will say self._zoom plus equals, let's say mouse.getDwheel. And we can just leave that how it is. So we're going to set our zoom equal to if we zoom in or zoom out. And if I press play, magic is going to happen, but not everything is correct yet. Look, we can rotate him. Oh, look at him. So you'll notice that on the top we have this black thing. That's supposed to be a runway. The window is kind of weird. If we zoom in, you'll notice it's just kind of blue. It shouldn't be blue. We're missing a lot of weird stuff. Like over here, this should be a little vent hole. And the reason is we're loading this texture wrong. So for some reason, the origin of this texture or of this model when we created in Blender is origin bottom left as opposed to top left. So when we're loading our texture, if we go to Entities Library, Texture Library, when we're loading our texture, all we need to do is invert our texture by going origin dot bottom left. Just like that. And if we press play, this texture should be aligned just right and all should be well. And yeah, you have that really cool purple beam from the back, and you have this really cool runway. There's like a vent for the, or like a nice cool window effect. So yeah, this is a 3D model, textured and everything. I hope you guys enjoyed this episode. If you liked it, like it, throw a little thumbs up on there. If you didn't like it, you can dislike it. It's cool. I mean, I understand. Just let me know what I could do better. And if you want to chat in Discord, let me know. Yeah. See you guys next time.